Hi class, welcome to exercise 10G, the remainder and factor theorems. In today's lesson, your examples and pre-learning will be example 13, using the remainder theorem, and your pre-learning for this example will be questions 1 and 2 in the new book and questions 4 in the old book. Then we'll do example 14, which is finding a linear factor. And your pre-learning for this example is question 4 in the new book, question 6 in the old book. And finally, we'll do example 15, applying the remainder theorem. And your pre-learning for this example will be question 8 in the new book and question 10 in the old book. Alright, so in this lesson though, we're assuming that you've mastered the concepts of the previous lesson. In particular, the concept of expressing a polynomial as a linear factor times a quotient plus a remainder. Alright, we'll see you in the introduction. So, what does it mean to be a factor? Well, a factor is something that divides exactly into something else. So what we mean by that is B is a factor of A if A divided by B has no remainder. So in very simple terms, 4 is a factor of 28 because 28 divided by 4 is 7. And 4 is not a factor of 29 because 29 divided by 4 is 7 plus a quarter. And to make these ideas align better with our theory from last class, really what we're saying is 28 is equal to 4 times 7 plus 0. And 29 is equal to 4 times 7 plus 1. So if 4 is a factor of 28, then 28 is a multiple of 4. So really it just comes down to whether or not there's a 0 or non-zero remainder. So this one's a factor and this one's not. And the same is true for polynomials, i.e. there's no remainder when we do a division. Alright, keep that in mind while we learn our new topic for today, which is called the remainder theorem, which is a really cool little trick. Let's say we try and divide our polynomial by a linear factor x minus b, and then it'll have some quotient and remainder. So in our last lesson, we learnt to express that as p of x is equal to x minus b times q of x, which is the quotient, plus the remainder. Now if you look closely at the divisor, if x is equal to b, the same b that's in the divisor here, then I could rewrite that statement above with b subbed in for x, okay? So that would give us p of b is equal to b minus b times q of b plus the remainder. So of course we've specifically chosen this b because when x is equal to it, we've got b minus b equals 0. And we could rewrite that now as the polynomial of b is equal to 0 times q of b plus r, and 0 times anything is equal to 0. So 0 times q of b must also be 0. I hope my zeros don't look like O's there because it could get very confusing with the Q. Anyhow, let's keep going. So, because that's equal to 0, we can ignore it and say that the polynomial evaluated with x of a value b will have to be equal to the remainder. So this means for the divisor x minus b, subbing in b for x in the polynomial gives us the remainder. Another maybe more long-winded way of saying that is we find a value of x that makes the divisor 0 and sub that in to the polynomial. So let's go back and have a look at some examples from the last class. I'm not sure if you remember, but we did x cubed plus 2x squared minus x plus 3 divided by x minus 2. And we also did 2x cubed minus x squared plus 3x minus 1 divided by x plus 3. Now hopefully you don't have any panic attacks here. I'm not going to ask you to do long division right now, but let's recall from these examples that the first one there had a remainder of 17 and the second one had a remainder of minus 73. So what the remainder theorem is telling us is if I sub in a particular value of x that makes our divisor 0, don't worry, we're not actually dividing by 0, it just means that the polynomial on the left here will equal the remainder. So let's try it for divisor 1 when we've got x minus 2 x minus 2 equals 0 means x equals 2. So let's sub in 2 for x into the polynomial. As always, I'd like to use brackets, and if you look at the line there for number 1, okay, so for every x up there, I've just put a 2 in the brackets. So we've now got 8, and minus 2 plus is positive 1, and that equals 17. All right, and next we have number 2, where the divisor was x plus 3. And another way of saying x plus 3, which will help some of you make a shortcut later, by the way, is that's equal to x minus 3. And obviously, this divisor equals 0 when x is equal to minus 3. So keeping an eye there on line 2, if we sub in the value minus 3 into that polynomial, then 2 times minus 27 is minus 54, and minus 9 plus minus 9 and minus 1. So 9 and 9 and 1 is 19, which is the same as 20 minus 1. So if we look at minusing from a minus, we end up with minus 73. Ka-ching, ka-ching. So it definitely does find what remainder we had from our division last lesson, right? Now, how do I use this to find factors? Well, putting together the way we've learnt to express polynomial division and what we know about numbers, we know that the polynomial of b is equal to the remainder when we divide the polynomial of x by x minus b. So, if we get polynomial of some b is equal to 0, it means that x minus b has to be a factor of x. Then if we sub in some b into the polynomial, and that's equal to 0, it means that x minus b is a factor of b of x, i.e. the polynomial x equals the divisor, x minus b, times the quotient that's left over, plus 0. Okay, because our division is for any x value, right? So then let's sub in x equals b. b minus b is 0. 0 times q of x is 0, so that disappears. So we get p of b equals 0. And the first line here is the definition of a factor. So let's have a look at a real example now. And this example here has a polynomial of x cubed minus 3x squared minus 3x plus 10. And while you're learning this level 10 class in Melbourne, then we won't be too harsh on you, and any of the factors will be whole numbers, and so therefore you're looking for factors of 10. So off the bat I can think of 1, 2 and 5 and 10 and their negative values. But let's try p of 1. We get 1 minus 3 plus 10 is 6. So that's no good. Let's try p of 2. So we've got 8 minus 3 times 4 is 12 minus 6 plus 10. And end up with 18 minus 18, so that's equal to 0. Therefore, x minus 2 is a factor of this polynomial. Okay, I've got x minus this value here, and it's also worth pointing out that it's a linear factor because x is to the power of 1. And let's prove that with some long division. So we've got x cubed minus 3x squared minus 3x plus 10. So it's a good chance to practice some more long division. Okay, so I'm going to multiply that by x squared, and then when I subtract that away I'll get minus x squared with the other stuff. So I'm going to multiply that by minus x, gives me the minus x squared and a plus 2x. So subtract that away, of course the x squares disappear, minus 3 minus positive 2 is minus 5x plus that 10. So the minus 5 times x minus 2 gives me minus 5x plus 10. Of course, let's put the minus 5 up there. And of course, there's no surprises here. The remainder is 0. So that means our polynomial is equal to that divisor multiplied by the quotient. And of course, you could factor this more if you want to do some quadratics. Okay, so that's the key idea. I'll go over the steps formally in the sections later on in this class, but for now you should pause the video and work on the building understanding questions in the new book, which translates to questions 1, 2 and 3 in the old book. because some of the basic concepts here will be basic to many of you, but there is a lot going on here and there's lots of room to slip up, so please do the building understanding today. Alright, we'll see you in that next section. Where we have a linear divisor for a polynomial, then that always equals some quotient plus a remainder. And of course the remainder is divided by the divisor as well. Then in our last lesson, we multiplied both sides and learnt to express the polynomial as the divisor times the quotient plus the remainder. And we saw some very simple examples with numbers. So instead of saying 8 divided by 3 is equal to 2 and 2/3, you could say that 8 is equal to 3 times 2 plus 2. So when we take this into account, if we subbed in the value b for x, then we would have polynomial of b equals b minus b times the quotient of b plus r. And the reason why we do this little trick is b minus b is 0, so 0 times q of b is also 0. So therefore this polynomial with x equals to b is equal to the remainder. So that means to find the remainder for the polynomial of x divided by x minus b, you only need to find p of b. In other words, the value of x where the divider is 0. Okay, so let's put this into action with example 13, where we're going to find the remainder when this polynomial x cubed minus 5x squared minus x plus 4 is divided by the following linear divisors. Alright, in part A, our divisor is x minus 2. So x minus 2 equals 0 when x is equal to 2. So subbing 2 into this polynomial, we get 2 cubed minus 5 times 2 squared minus 2 plus 4. And 5 times 4 is 20, and 2 cubed is 8. So we've got 8 minus 20 plus 2, which is equal to minus 10. Therefore, the remainder of p of x divided by x minus 2 is minus 10. Alright, let's have a go part B, where our linear divisor is x plus 1. So x plus 1 equals 0 when x equals minus 1. So subbing that minus 1 in gives us minus 1 cubed minus 5 times minus 1 squared minus minus 1 plus 4. Ooh, we sort of ran out of room there, but hopefully you can read that. So we're left with minus 1 minus 5 plus 1 plus 4, which is those 5s and the 4 cancel out, so that's minus 1. So therefore the remainder for p of x divided by x plus 1 is minus 1. And you're welcome to check them out if you want to practice your long division. But anyhow, you need to pause that video and get on to questions 1 and 2 if you have the new book, or question 4 if you have the old book, and then we'll see you in the next section. Because a polynomial evaluated at the value b tells us the remainder of that polynomial divided by x minus b, then if polynomial b equals 0, that means that x minus b is a factor, because p of x divided by x minus b has a remainder of 0. Also, when we're saying we're looking for a linear factor, x minus b is a linear factor because x is raised to the power of 1. So let's try this out with example 14, where we're going to decide if the following are linear factors of the polynomial p of x equals x cubed plus x squared minus 3x minus 6. Okay, part A, we have x plus 1. You could decide where x plus 1 equals 0, or you could rewrite that as x minus minus 1, and realize that we're talking about x minus b, so in this case we're talking about minus 1. So let's try subbing in minus 1 into the polynomial. So minus 1 cubed is minus 1, plus 1, minus 3, so plus 3, minus 6 makes minus 3. So we don't have a remainder of 0, therefore x plus 1 is not a factor. Alright, part B, we're going to try x minus 2. So this is straightforward, we've got the minus sign in there. So let's sub positive 2 into our polynomial. So we've got 8 plus 4 minus 6 minus 6, and that's just 12 minus 12, which is 0. So therefore x minus 2 is a factor. Alright, that's not much harder than the last section. You're just looking for a specific answer this time. Alright, pause that video now and do questions 4 if you've got the new book, or question 6 with the old book. And then I'll see you in one more section. And now that we've covered the remainder theorem, this section is just a test on how much of the concept you've grasped, as well as general algebra skills. So let's pop straight into example 15 and see what I'm talking about. So the question is asking you to find a k. Well, actually, let's just write out the polynomial first. Okay, so we got x cubed minus x squared plus 2x plus this k, and we have it divided by x minus 1. Now the question is asking you to find a k such that this situation has a remainder of 5. So when we've got x minus 1, or divide by x minus 1, the remainder equals 1 subbed into the polynomial. And then when you look at the question again, we're trying to find a p1 that's equal to 5. Okay, so that's just using the remainder theorem. So we can now sub 1 in for x. Alright, so we've still got the k there, and we've now got it equal to 5. So if we evaluate all those squares and cubes, well, it's just 1. So it's 1 minus 1 plus 2 plus k equals 5. And when you see a question that says find k, what they're really saying is solve for k. Though there are some funny memes going around where students have, there it is on a test when they're asked to find x. I won't laugh if I'm marking it though. Alright, so it's quite simple from here. We just need to subtract this over to the other side. So this is 1 minus 1 is 0, which is 2. So if I sub 2 across to both sides, then k is equal to 3. So we've solved for k, and you could check. So with k equal to 3, we've now got x minus 2 dividing into, or really I should have said x cubed minus x squared plus 2x plus 3 divided by the x minus 2. So that 3 is replacing the k, right? Anyhow, I'm actually not going to check. You can check. But if the remainder theorem's correct, we should have a remainder of 5, right? Not 5 factorial, anyhow. Alright, so pause the video now. Do question 8 if you've got the new book, question 10 if you have the old book. And then when you come back, we'll be able to summarize this lesson. So this lesson was continuing our exploration of division. And now that we're finding factors, you can probably guess that this leads to solving and graphing. So make sure that you take your time to master the long division from the last lesson, and also add some time on that to really absorb the remainder and factor theorems. Alrighty then, for this lesson, a successful student will know how to use the remainder theorem to find the remainder when a polynomial is divided by a linear expression. Understand that the remainder of 0 implies that the divisor is a factor. And finally, be able to use the factor theorem to decide if a linear expression is a factor of a polynomial. Alrighty, that's it for today. It goes without saying that you need to keep working hard and make sure you're getting on the front foot and getting support when you find yourself in a sticky spot. Alrighty, see you in the next class, whether that's in the classroom or on a video. Bye.